talk some today about introducing disruptive technology into the marketplace. And at NatureWorks, you can see a picture of our plant there. We make polylactic acid, and how we make that is by taking sugars or dextrose and fermenting that. Instead of fermenting into ethanol, we ferment it into lactic acid. That lactic acid is then converted into a monomer. It's essentially two lactic acid molecules put together called lactide. And then those lactide molecules are ring open to make a polymer, very long chain of materials. Back in 1989, Cargill research facilities, and I don't know if any of you have heard of NatureWorks or Cargill before by hands, anybody? Okay, a couple, yeah. So we started as a Cargill research project in 1989, and the whole idea was let's introduce a new-to-the-world polymer that utilizes an abundant feedstock. And at that time, in the late 80s, Cargill had carbohydrate processing facilities around the world, still do today, and they were looking for higher value outlets for some of those facilities. So the idea was to introduce a new-to-the-world polymer. And if you look at the history, this slide here is showing you a history of the resins. Here you can see a lot of the commodity-type resins that have been introduced. And this is really a scale of how long since initial commercialization until they were selling or commercializing over 300 million pound a year rate for those materials. You can see our material here stacks up somewhere between what I would call the traditional commodity resins and the specialty resins, you know, the nylon, the ABS, the PMMAs of the industry. And NatureWorks has been at this, like I said, since the late 80s, and it's not for the faint of heart. And we'll get into that here in a second. You can see the history of PLA actually really was discovered by brothers back in the 20s. And Cargill's project in the R&D facility, that's a picture of it here, started in the late 80s, early 90s. We built a semi-works facility in the around the 94, 95 time frame, and we built a large manufacturing facility in 2002. Just rough order of magnitude, the scale of these facilities we're talking about, investment-wise, millions of dollars, tens of millions of dollars, many hundreds of millions of dollars for investment. And so when we talk about not being the faint of heart, I don't think I'd be up here talking to you today about the success of NatureWorks if it wasn't for the really large-scale investment that was made by Cargill Dow. Cargill partnered with Dow in the mid-90s, and they made a very large-scale investment, a 150 KTA facility that really enabled NatureWorks to compete against petroleum-based products in the marketplace. And I highlighted in blue here some of the key milestones for our lactide monomer business that I'll be talking more about later. It really ties into why is NatureWorks here talking at an adhesives conference. You can see what we've established in the marketplace. And this past year we hit our 2 billion pounds sold of our Ingeo material. Ingeo, by the way, is a trade name for PLA, polylactic acid. So we sold over 2 million pounds in this past year. You can see our compounded annual growth rate over the period. What's resulted in those investments I referenced earlier is a broad range of diversified applications in our portfolio that are sold around the globe. We roughly sell 40% in North America, 30% in Europe, and 30% in Asia. And you know, so some of the areas that people are probably most familiar with would be the food service applications, maybe some in the same 3D printing, we're used in the filaments. But we're also used in a lot of other applications, beauty and household electronics, building and construction, medical. We also do a lot of the medical drapes and non-woven applications. And again, landscape, agricultural fabrics, and of course cartons and non-food packaging as well as food packaging. So a wide range of applications, and there's many, many more in the pipeline. So we've been at developing our thermoplastic business for, like I said, 15, 20 years. So when you introduce a new technology into the marketplace, this is the Gartner height curve, and I think it's really appropriate for a lot of lessons that we've learned at NatureWorks over the years. I see people getting a chuckle there. It starts out with a lot of excitement and probably some irrational exuberance about what you're going to do in the market. Is kind of build it and they will come, and we got a bio-based material and the plant's going to sell out in a year kind of mindset. And then you get out in the marketplace and you get some feedback, and sometimes the market's good, sometimes it's bad, but you can always count on getting feedback. And you go through what I would characterize as a trough of disillusionment. Others may call it the valley of death. Call it what you want, but sometimes it's a harsh reality when you get that market feedback. And then you get into an area of slope of enlightenment or plateau of productivity, where you really start to understand what it takes to make your product work and how to make it work in the marketplace. And for NatureWorks, we matured over the years, and we were no different. And I'm going to tell you some stories, not all the stories. I could write a book about it, but I'll tell you some of the stories about NatureWorks' journey. And incidentally, I joined NatureWorks right about here. All right, so talk some about some of the early adoption and market activities and business adventures or business activities we had at NatureWorks. So early on, we really started, we had really high aspirations. We had aspirations of us as a company, and the market had very high aspirations of NatureWorks. You could see, articles from the Washington Post, Forbes, others, really, talking about the latest sexy green polymer that was out there in the marketplace. For us, we also had some internal aspirations that I think were quite naive at the time. I could remember having arguments or discussions about not wanting to blend our material with non-bio-based additives. Having a purist type of mentality where we said, hey, if it's not bio-based, we don't want to put it in our material. And it was just, we weren't focused on performance at the time. We were in the illusion that, hey, you build a bio-based polymer plant, people are going to buy it because it's green and it's bio-based and has a great end-of-life story, and that's all that was needed. We started out and really focused on apparel as one of our big market segments that we were going after. And I don't know if folks are familiar with the apparel value chain, but it's very complex. Numerous converters, dye manufacturers, additives throughout the chain, very complex value chain. And for us to drive a new material into that chain with that complexity was really, really challenging. You see our former CEO, Kathleen Bader, picture here on the cover of Forbes talking about the launch of this fiber business and how exciting and how we're going to have 10 plants built according to the McKinsey surveys in the next 5 years. So we had huge aspirations. So we were clearly on this part of the curve here where we were thinking that it was going to be the best thing that ever happened. And then we did some of the market feedback, and we realized that we didn't have enough pull-through in that value chain to really drive change that was necessary to commercialize. And we really, that was an application area for us that we quickly pivoted from that, and we went into our fresh food packaging. So here's a picture of one of the applications that we're going after in the fiber and apparel of Versace, a sports coat that had some of our fiber in it. We quickly pivoted to fresh food packaging, and that was an area where the value chain was much simpler. There we had Walmart as a retailer had a sustainability program that we fit in nicely with, and we really could as I said, much simpler value chain. They had the ability to pull stuff through that chain. And so there we had some reasonable market adoption, but again, we were missing some things. And it was really, both of these approaches were really driving at a drop-in replacement for PET, and they weren't really capturing the unique properties and trying to take advantage of the unique properties that PLA has to offer. And so, I can remember going to trade shows and conferences where people would get up and present and talk about how PLA didn't work. And I'd be sitting back there saying, what are you guys doing? And a lot of times they were just checking the box. It was just a mentality. I'll find a difference between what I'm comparing it to, whether it's polystyrene or PET or polypropylene. And they'd say, well, this particular property is inferior. Well, yeah, it's different. It's, but you didn't cite the 10 other properties where it has an advantage. But you could just see it was, well, I told my sustainability boss, I need to look at this new material, check the box. I found the differences here. I report out on it. We're done. Let's move on to something that we're used to using in our formulations and our applications. So, some of the key lessons that we learned there were it's really important to have a simple value chain. It's really important to have brand owner pull through, and it's really important to work on properties that are inherent to your materials that really drive performance. And so, the next what I'm going to talk about really is a sun chips bag. And most of you probably remember this back in 2009. Frito-Lay and Pepsi announced the rollout of a compostable chip bag. And it really started in 2009 and very thoughtful and considerate in how they approached the market with this. They first launched a printed bag in limited market space, and then they added an adhesive layer. This was normally a polypropylene film, which is used in a lot of chip snack applications, and here we're replacing polypropylene with PLA film. And in the first rollout, they were really taking advantage of the unique printing properties that PLA films have. We have great printing, printability for a film. And so that was something they really liked and were taking advantage of. And then they added the barrier layer on layer in the process. And in 2011, they had mass marketing and had the chip bags fully launched. And we're in retail stores around the United States with our chip bags. We're pretty excited. But again, we got some market feedback. Wall Street Journal, early morning, America Show. It's not about being green. These bags are really too noisy, right? They were coming in at about 85 decibels. You couldn't go downstairs and sneak a chip when you were on a diet. Everybody in the house could hear you. It was just, it was a bad thing. So, it's one of those lessons learned, that we joke about, but it's really the material has to work in every aspect and not just a couple. It's got to really provide differentiated performance and deliver values to consumers, not just in being bio-based or in being compostable or having a great end-of-life story, but it's really about understanding exactly what you're trying to deliver to the market. So now I'm going to talk about a couple applications that are in our growth platforms that are where we have unique properties and we really can deliver some unique performance and value to the market. So this first one, and I have to admit, at NatureWorks, I was a little bit of a naysayer on 3D printing when it first came out, and I was like, this is just a fad, it's a hobby, it's going to go away. And I was wrong and quite pleased and amazed at how much adoptions occurred in the marketplace. The thing here about PLA in this application, or NGO in this application, is it prints extremely well. It is really the material of choice for 3D printing. Not only does it print well, but you don't have to have a heated chamber. You don't need a heated platform to build off of. And it really, in some of these applications, you can see in the foundry and medtech, we think we offer some unique performance properties there, especially in the foundry where when you try to make a casting and prototype where you're trying to get something cheaper and faster there, our burnout is really clean with respect to a foundry application. You can see here at MedTech, this was from the University of Minnesota, where they actually were trying to do some 3D modeling before the surgery. And so a lot of unique opportunities and applications here in 3D printing. We're excited about it. We think it's yet to be determined how much growth there's going to remain in that market space, but it's something that really has caught our eye in the last 5 years. Talk about a couple more. Here is a hygiene application, and here it is an application where we are replacing polypropylene in a diaper. And usually you have a top sheet, and you have an ADL, and then you have absorbent core, and then in this core you have the SAP polymer, super absorbent polymer. And the real purpose of these top sheets, of course, are to let the insult go through and to attain all the moisture down here. And if you have a re-insult, you want the same thing to occur and have your SAP pick up the insult in that part of the diaper. We offer performance properties that are significantly better than polypropylene in this application. From a strike-through, runoff, re-wet, we match or exceed what polypropylene does. And to top that off, you can use 30% less SAP in the diaper. SAP is the most expensive part of the diaper. So this is an area where not only we provide performance, but we're also got a cost play and a performance and a value play that is very interesting for us. Switch gears and talk about another application. And here is a application where we see a market demand, really an unmet need in the marketplace is about recycling the compostability. And if you look at coffee cups, the single-serve coffee cups, the K-cups, or in Europe, the Nespressos, you have a cup, you have a filtering device, and you got a lid. We offer solutions for all three of those. In addition to offering a solution, end-of-life solution, we also offer improved taste and aroma, and we also offer performance in high temperatures and pressure systems. So again, back to our learning of, hey, it has to work in all applications. And also providing a barrier system in addition to high temperature and pressure is something that we offer. So for us, this is a great area where we see an unmet need in the market, and we're well on our way. We have a couple of these commercialized, and we have many more on the development pipeline that we hope to get out into the marketplace in the next couple of years. So this is an exciting area where we clearly have fit for use and performance advantages. So you say, oh great, love to hear all these stories about NatureWorks and thermoplastics. Why am I at an adhesive conference talking, right? And you guys probably wondering what's he up to. So I talked earlier about our lactide, and we have unique chemistry here with our lactide, and we think that lactide intermediates or monomer can be used to really go after reactive hot melts and non-reactive hot melts. As well as going after some resins that we think are going to be good in the adhesive space. We've really made some investments. I mentioned in 2010 we started into marketing our lactide. In 2011 we put some capital in. We recognized right away that we didn't have the depth or the breadth of offering there, or the quality, and so we put some capital in to really offer an improved offering in this space. And that was done in 2012 and 13. And in 2017, we announced the launch of our Versat product line platform, which is really talk more about that. So why did we want to get into this space? And for NatureWorks, we heard Coach L this morning talking about teamwork and the importance of the team. What NatureWorks really brings to the table is 20 plus years of chemistry expertise and experience in the lactide monomer and lactic acid polyester chemistry. And we're taking those 20 years of experience and really applying them into an area. Here, this is high molecular weight semi-crystalline polymers, and we're really taking that same chemistry knowledge and applying it into amorphous low molecular weight materials that we think are really well suited and fit for the adhesive market space. And the amorphous material gives us lower viscosity for giving molecular weight, better flow at a lower processing temperature, better wetting on a substrate, better solubility in solvents for lower VOC formulations, and of course angry control for functionality reactive adhesives. So we think we have our chemistry has a great play in this space, and we think we, with our large-scale manufacturing plant in Blair, Nebraska, have a great offering, economies of scale to really help drive some innovation. So we realize it's not just about selling a mono, but it's also about, it's more about offering a business solution and a platform for us in this space. And the importance and what we really bring is trying to accelerate and understand where we bring benefits and how we can move through the prototyping and the R&D process quickly into a commercial solution. And that's ultimately what our years of experience and knowledge in the polyester world and the thermoplastic world, we hope to apply that in the adhesive space. So to kind of sum it up, NatureWorks has a very large-scale manufacturing plant in Blair, Nebraska, 150,000 metric tons. We've hit our 2 billion pounds sold milestone. We have a dedicated application development team. We've got scientists that worked at 3M, HP Fuel, Dow Chemical. We really have a team that is, I would call, world-class experts in lactide and polylactic acid chemistry. We're jointly owned by Cardinal and PTTGC. We have global market channels, and we have a strong environmental expertise and product characteristics. NatureWorks has been in the space for, I said, like 20 years. I think, if imitation or mimicking is as a form of flattery, we are being followed by Total Corbion. They announced a plant that they're going to finish construction on in Thailand, a 75 KTA facility that will also produce and sell polylactic acid and lactide monomers. So for those of you that are concerned about putting all your eggs in one basket and only having a single source, PLA is going to be around for many, many, many years, and I'm happy. We're very encouraged about having emerging competition coming into the marketplace to offer dual source supply of both lactide and PLA. So we think, again, we have a lot of great chemistry to offer the adhesive arena, and we're very excited to hopefully get to know you folks better. This is our first time at the conference, and I think we're very glad to be here.